Previously, you've seen an application of loops with arrays. I want to bring you back to that application now that you've seen what while loops are. The problem I want to solve is whether or not an array is a palindrome. An array is a palindrome when the terms of the array are read the same from left to right and right to left. As an example, take this array. The array is a palindrome as it reads the same from left to right and right to left, but an array consisting of the terms 1, 2, 3, 4, 5 is not a palindrome because it does not read the same from both directions. In order to see if the array is a palindrome, an approach we can use is to move through half of the array and check if both elements on opposite sides of the midline are the same. Let's run through an example. First, we will start by marking the midline so that it's easier for us to visualize. Starting the while loop, we will first look at the elements starting at 0. Then we will take a look at the elements on the opposite side of the midline. The element at the opposite side of the midline is the last element in the array. As they match, we can continue looking at the element at index 1, and comparing it to the element at index 4, we see that they match. The last comparison we'll make is with indices 2 and 3. As we can see, they match and we can return true. Let's get to coding. At the top, inside of the main method, we create the array. So type out int square brackets array equals, now type out 2 curly brackets, and then we'll leave this blank for now. We'll fill it in later. After, we create a boolean called isPalindrome, and we'll set it to true. This variable will tell us if the array is a palindrome. Afterwards, we'll create an int, and then we'll initialize it with a value of 0. This will keep track of the index. So we'll type out while I is less than array.length divided by 2. This means that the loop will run to the middle inside of the while loop. We'll check to see if the element at index I and the element on the opposite side of the midline do not match. To do this, we will write out the condition if array at I is not equal to array at array.length minus 1 minus I. To find the element at the opposite side of the array, we just subtract our index from the index of the last element of the array. The index of the last element of the array will be array.length minus 1, and we can subtract I from it. If this condition has been matched, we automatically know that the array cannot be a palindrome, so we'll set isPalindrome to false. Also, remember that if the if statement only contains one line, we do not need to add the curly braces. After the if statement, we can increment I to move through the array. We don't ever need to set isPalindrome to true after initialization, because if the variable has been set to false already, all the pairs match up and we already know that the array is a palindrome. So before we run it, let's go through some tests. Our first test will be with the array 0, 3, 3, 0. At the top, we can keep track of I. I is 0 and half the length of the array is 2. 0 less than 2, so we know that we can enter the loop. We will now check the condition of our if statement. Array at I is equal to 0, and array at 4 minus 1 minus 0, or array at 3 is also equal to 0. Since they match, we do not enter the if statement, and we can increment I. I is now equal to 1, and heading back into the condition of the while loop, we check if I is less than 2. Since it is, we can enter the loop. Checking the condition of the if statement, we can see that array at I is equal to array at 4 minus 1 minus 1, so we do not execute the code in the if statement, and we once again increment I. Heading back to the top once again, we check the condition. We can see that I is not less than 2, so we can exit out of the while loop. Our next test will be with an array with an odd number of elements. Entering the method, I is declared and initialized with a value of 0. Now at the condition of the while loop, the length of the array divided by 2 is equal to 1, because we are dealing with integer division, meaning that the decimal is cut off. 0 is less than 1, so we can keep going inside of the while loop. Checking our condition with the if statement, we can see that it is true, So we skip the body and increment I to 1. Back at the condition of the while loop. 1 is not less than 1, so we exit out of the loop. We do not need to check the middle element because the middle element will always be equal to itself. Our last test will be with an array which is not a palindrome. At the top, one last time I is equal to 0. We pass the condition of the while loop and we can now enter the loop. We check our condition with the if statement. Since 5 is not equal to 98, we can set is palindrome to false. Now, all that's left to do is actually run the code. Let's plug in our examples. In our main method here, we can plug in the numbers inside of our array. So for the first one, we'll type in 0330, and then at the bottom, we can print out the variable is palindrome. Now let's run the program. So we'll type out javac palindrome not java, and then we'll type out java palindrome. And then when we run it, we can see true is returned, and which is indeed correct. Next, we'll type in our second array, which is 818, and then we can run it again. So we'll compile first. Whoops. Palindrome. Then we can see that true is returned once again. And then if we type in the last array, which is 598, so do 598, and then we can do javac palindrome.java, and once again java palindrome, and we can see that false is returned, which is the correct answer. We have just written our algorithm to check whether or not our array of strings is a palindrome. Our solution can be implemented with for loops. Try it yourself and have fun.